Let's explore one of the foundational concepts of algebra, of functional algebra, and that is function notation. Very simple. Most students, though, get used to applying it to equations, and so they get lost whenever there's a different way to represent a function. So we're going to explore it, emphasize the concept so that it can be used across the board when dealing with functions. All right, so the first thing in function notation is we want to name our function. So we're gonna name our function. Maybe we'll call it f. That's a common function name. So the first thing you start with is the name. Okay, and then what we do with the function is we give it an output, and the function, or we give a function an input, and it gives us an output. So we have to now give this guy an input. And the way we do that is in parentheses next to the function name, the function, in parentheses, we put our input. So whatever's in the parentheses next to the function name, that's your input, okay? And then we say, all right, what's the output? And the way we say that is we say function name, parentheses, input equals the output. Okay, and the way we read this is it looks very much like multiplication because we have what looks like a variable f next to something in parentheses, which typically means multiplication in mathematics, except for this case where the context tells us that we have a function here. If this is a function, that means this is an input for that function. So we say this as f of input equals output. F of input equals output. You might want to write that out in quotation marks. F of input equals output. All right? So what's in the parentheses is your input, and f of that is your output. So let's think of this as, another way to think of it is f of x equals y. So what's in the parentheses is your input, which we typically label as an x value, and that whole thing, after this input runs through this function f, we get the output y, okay? So f of any input is the same as y, okay? So x alone, what's in the parentheses is your x, and then once it's f of, that whole thing means y. So those are some fundamental ideas that we need to keep in mind as we run through. The item in parentheses by itself is the input, and the entire expression, sorry about the light, the entire expression is your output, y, okay? So let's practice with this now. All right, so let's consider this mapping. We'll use a mapping, a set of ordered pairs, and a graph to sort of understand this concept. So we'll have a mapping, a set of ordered pairs, and we'll have a graph, all three of which can be used to represent relations or functions. So the mapping we will call f, and the inputs are 2, 3, and 4. The outputs, let's say, are -1, 5, and 3. 2 points to -1, 3 points to 5, 4 points to 5, and also to 3. Now, one important thing to notice is that this is not actually a function. So we can apply function notation to relations that aren't functions as well. So we'll keep that in mind. It's not a function because the input of 4 has 2 outputs, okay? Now our set of ordered pairs we'll call G, which we will list as the ordered pair 1, 2, 3, 4, and 5, 6. Okay? And then finally our graph. I should have brought graph paper, but that's okay. We'll improvise here. We'll keep it just a straight line. And let's say at 3 on the x-axis, we have an open circle. And then it's diagonal, slanted up as we go to the left. Maybe it looks like that, okay? All right, so there are 3 relations, and we're going to explore function notation with each of them. So let's say over here, I want to know f of something. And by the way, the function name doesn't always have to be f. It could be g, or let's call this, we'll label this relation as h, okay? Oftentimes that part of the alphabet, F, G, and H, are used for function names. That's pretty standard. Anyway, your function name could be anything. So f parentheses, let's say 3. F parentheses 3. And how do you read that again? We read that as f of 3. And what it's saying is, all right, what is f of 3? Well, f of 3 is an output. F of 3 is an output. It's a y value. It's the output whenever the input is 3. Write that down if you need to. We're looking at f, and we want to know the output of f when the input is 3. And well, we can tell that the output, when the input is 3, the output is 5. So the way we write that is f of 3 equals 5. Okay, f of 3 equals 5. Now let's look at g of 3. G of 3 means this is an output, and it's the output of the g function or the g relation when the input is 3, when x is 3. So we scan our order pairs looking for an x value of 3. Here we go. And the y value associated with that, or the output associated with that, is 4. So g of 3 equals 4. Okay? Now let's look at h of 3. H of 3. So when we look at this graph, we need to know the output of h when the input is 3. The y value when x is 3. So we scan our x-axis. The x value of 3 is here. And the y value is the point on the graph, is the y value for the point on the graph where x is 3. So we're looking at this vertical line for any points on the graph. Well, the only point that could potentially be on the graph is where this open circle is, and the open circle precisely means that point is not on the graph. It's an open boundary point. So h of 3 does not exist, or so I'll use D and E for does not exist, or we could say h of 3 is undefined. There is no output of the h function when x is 3, when our input is 3. So that you could write D and E, you could write undefined. You wouldn't write no solution, by the way. You use the terms no solution when you're trying to solve an equation, right? A solution has to do with solving something. Here we're not solving anything. We're just trying to find the value of this output. All right, let's do a couple more. Let's go back and let's look at g of 1. So you can see the importance of having the name here because it tells you which relation to look at. We're looking at the g relation, and g of 1 is the output when 1 is the input. Well, that's 2. G of 1 is 2. And let's do a couple more. Let's say we have h of 0, meaning the output of the h function when x is 0. Well, x is 0 right there. And let's just say that this y value, let's say that this y value is 2.5. So whenever I'm looking at 0, the output of this function is the y value 2.5. Okay? All right. Now let's do one more. Let's say we've got f of 4. F of 4. So what's the output of the f relation when the input is 4? Well, f of 4 actually has two outputs. F of 4 outputs 5 and 3. So f of 4 equals 5 and f of 4 equals 3. You see how weird that is, right? F of 4 equals two different things. And so that's why we're interested in functions, because this can't happen if f were a function. F of the input would give us one answer, okay? So it's kind of weird when you look at a relation that's not a function, especially when you have function notation. So anyway, that's function notation, very basic. The key is what's in the parentheses is x, and the entire expression represents y. So if you want to know what the entire expression equals, you're looking for the y value for that given x value.